Very good morning, children. Children, today we'll discuss one very important topic of chapter number 7, that is alternating current, and the topic is transformer. So let us see about the transformer. See, these are the points related to transformer. So in this topic, first of all, we'll learn about the definition of transformer, then its principle, then design and description, then what are the types of transformer, then we'll move for the calculation of voltage, that is input voltage and output voltage, relation between them, and then after calculation of current, and what are the various uses of transformer, and at last we'll close up after studying about losses in transformer. So this is the diagram of transformer, in which this is the primary coil, this is the secondary coil. There is no any hard and fast that this one is always be a primary coil, means the coil, through the coil which in which we provide the input, we supply the AC, then that that coil is termed as primary coil, that is called input, and here it is load, across this load will get output, therefore this will be the secondary coil. So primary coil, the coil through which we apply AC, and the secondary coil, the coil through which we can get output, is said to be secondary coil. So primary coil के क्रॉस हम इनपुट देते हैं, secondary coil के क्रॉस हम आउटपुट लेते हैं. So this is just for the study purpose, but the actual diagram, actually transformer is made up with the help of so many plates, that is so many cores, so many soft iron cores. The actual shape of the core of this transformer is this. So let me tell you about the definition of transformer. That is, it is a kind of device which change voltage as well as current of AC supply. So the device which is used to change the voltage as well as current of AC supply is said to be transformer, you may say, right? Okay, so this is the definition. Now let us see principle of transformer. Principle. See, transformer works on the principle of mutual inductance. It works on the principle of mutual inductance. So please remember this. This question may comes in 1 marks. So tell me in what on which principle the transformer works. So the answer will be mutual inductance is the principle on which transformer works. So let us see design and description. Dear student, transformer is made up with soft iron core, having so many staples which are varnished See, each and every transformer is varnished, dipped into the varnish, so that the staples can become insulated. Okay. The staple is designed in such a way that eddy current can be minimized. Later we'll discuss about the eddy current in losses in transformer. So अभी फिलहाल आप इतना ही समझिए कि ये स्टेपल्स की डिजाइन इस तरह से इसलिए बनाई जाती है बच्चों, क्योंकि एडी करंट whenever there is a change in magnetic flux linked with a plate, iron sheet, and a position is induced, and that opposition causes eddy current, and because of eddy current there will be production of heat, and heat is a kind of energy. That's why there will be a loss of energy due to this eddy current. So the design of staple can be made in such a way that, suppose this is the direction of current, here current, see this current, this. So you may say this is the path of the current. See, the path of current, that is L is increases, and when L is increases, what will happens? Resistance of a conductor depends upon its length. When L is increases, what will happens? Resistance also increases, and by this formula I is equals to V upon R. If R is increasing length, if R is increases, so V upon R decreases. If V upon R decreases, current also decreases, and if current also decreases, then by this formula H is equals to I square R. So if this I is decreases, then ultimately production of heat also decreases, then there will be minimum loss of energy while transmitting from one place to another place. Got my point? Very good. So this is all about design of the transformer. So let me tell you about next point, that is types of transformer. Before that, there is a simple calculation. See, this is VP stands for primary voltage. Here IP is current in primary coil. Here number of turn in primary, NP stands for number of turn in primary coil. In the same way, here NS number of turn in secondary coil, VS output voltage, and IS current across secondary coil. So according to Faraday's second law, that is EMF induced is equals to rate of change of flux. So whatever EMF is created in this primary coil totally linked with the secondary coil. So as per this law, the EMF induced, or you may say applied EMF across this coil, across primary coil having number of turn NP, will be equals to eta primary will be equals to minus NP d phi B upon dt. Further it can be written as Vp. So suppose this is equation number 1. This equation shows the applied EMF across coil, across, you may write, primary coil will be this. Similarly, you know, EMF induced across secondary coil having how many turns? Very good. NS having you may write number of turn NS will be Vs is equals to, you may write eta S is equals to Ns here d phi B upon dt. This is equation number 2. Here we have taken whatever the flux is created here, total flux linked with the coil number 2, that is secondary coil. So now just divide equation number 2 by 1, will get from equation 1 and 2 we get what we get, children, see. So Vs upon Vp will be is equals to minus Ns d phi B upon dt and divided by minus Np again d phi B upon dt. So this cancel with this cancel with this. Finally we will get Ns upon Np is equals to Vs upon Vp. Dear students, this equation can further be written as Vs is equals to Ns upon Np into Vp. This is the another format of the same equation. See here, Ns upon Np is called, this is called transformation ratio. This is known as transformation ratio, and later will tell if Ns upon Np is greater than 1, then the transformer will be step up transformer, and if this ratio become less than 1, then it will becomes step down transformer. Okay, so see this equation here. If number of turn in secondary coil is increases, then voltage across secondary coil will also be increases. This is directly proportional to output voltage. Vs stands for voltage across secondary coil, or you may say output voltage, while Vp stands for input voltage or primary voltage, you may say. See, suppose this is equation number 3. From equation 3, if you know ns is greater than np, then what will happens? Then vs will also be greater than vp. This is how equation number 3 shows. Suppose we want to increase the voltage across secondary coil, that is we want to increase this V across secondary coil. What we have to do? We have to take the number of turn in the secondary coil more compared to number of turn in primary coil. Got my point? Very good. So on this basis, on the number of turn in primary and secondary coil, we can tell about the types of transformer. So I hope up to here any problem? Very good. So let us see about